So this is the 2014 Junior Cert Higher Level Paper 2 and we're looking at question number 9. In the diagram below, the size of the angle MNP is equal to the size of the angle P or Q. So in other words, we're saying that MNP, which is this angle, is equal to P or Q, which is this angle there. So they're equal. Okay, part 1 says prove that MNP, the triangle MNP, and the triangle QRP are similar. Okay, so if we're trying to prove similarity, what you want to prove is that the three angles are the same. In other words, angle, angle, angle. If you can prove angle, angle, angle in the two triangles, then you can prove that the triangles are similar, which means they are, one is an enlargement of the other, but the three angles are the same size, corresponding that is. So the triangle MNP, which is this one up here, MNP, this small triangle, well, what do we know? We know that, first of all, what we're given, the size of the angle MNP, that's equal to the size of the angle P or Q. That was given to us. Now, we also know then that this angle here, we also know that this angle here and this angle here are equal as well because they're vertically opposite. So this angle here, which is MPN, so the size of the angle MPN is equal to the size of the angle QPR. QPR. So they're equal because they're vertically opposite. You must give a reason for each thing you're saying. Okay, and then finally, the third angle, in each case, this one and this one, they must be the same because if two angles in a triangle are the same, then automatically the third ones are the same as well. So we can call that, the first one is the size of the angle NNP, that's that one, and that's equal to the size of the angle PQR. Third angle in a triangle. That's the reason there. So therefore, the triangles are similar. That's our proof. Okay. Part 2 says, is NM parallel to QR? And give a reason for your answer. Well, NM is this line, and we're saying, is this parallel to QR? Well, because these two yellow angles which were given, because they're equal, and this line NR is crossing the two lines that we're talking about, that means they're alternate angles. So NM and QR must be parallel. So the answer is yes. And the reason is that the size of the angle MNP, which is this one, is equal to P or Q. I'm just going to write here as well that they're alternate angles. Therefore, NM is parallel, this is a sign for parallel, to QR. Okay, given that MN is 6 NP is 4, QP is 9, and POR is 10. Find QOR, the length of the line QOR, and the length of the line QM. Okay, so we know that the triangles are similar because we've proved that. So with similar triangles, you can find missing sides using scale factor and so on. So I'm going to put these measurements in first of all on the diagram that was given. So MN is 6 and NP is 4. MN is 6 and NP is 4. QP is 9 and POR is 10. So QP is 9, that's this side, and POR is 10, that's that side, that length there. Okay, so when you're doing similar triangles, it's a good idea to rotate the two triangles so that they're oriented the same way. So I'm going to do that over on the next page. I'm going to do QPOR as it is. So in other words, I'm going to have QPOR like this. So QPOR. So there's QPOR with 9 and 10. And then I'm going to draw this triangle here as if I rotate it around. Imagine rotating it around so that it's MPN. It's going to be the smaller one, rotate it around like this, draw it separately. MPN. The M and the N would switch sides when you rotate. And when we do that, we can see that MN was 6 and NP was 4. So MN was 6, NP was 4. So there we go. We have the two similar triangles, like so. So once you have that done, you have them oriented the same way, well then you can find two corresponding sides. So we can see that PN corresponds to POR. So 4 and 10 correspond. So we can use this to find the scale factor. So the scale factor is the big divided by the small, so it's just 10 over 4. And 10 over 4 is 2.5. So that's our scale factor, 2.5. So when we're looking for QOR, which is this side here, to go from the small to the big, you would multiply by 2.5. So I'm going to multiply 6 by 2.5, and 6 by 2.5 gives me 15 for QOR. So QOR is 15. And then to find QM, which is QM is, if we go back, Q to M, this distance, we want Q to M. Okay, so we know that Q to P is 9, so we just need PM. So if we go back here, trying to find PM, which is this side here, well, we know that this side here is 9, that corresponds to PM. So if we're going from big to small, we divide by the scale factor. So we're going to divide by 2.5 there to find PM. So let's be clear that QM, which we're looking for from the diagram here, QM is QP plus PM. And that's equal to QP, which we know already is 9, plus PM, which is 9 divided by 2.5. So you can do that in your calculator. That's 3.6. So when we add the two of them together, that gives us 12.6. So QM, which we were looking for, is 12.6. So that's the end of part 4 and the end of question 9.